Okay, so you need two things, your homework from last night and for Thursday night, and then also a calculator, because we will definitely be using that today. So if you don't have those, go ahead and get them. And let's go through the homework first of all. So let's start with number 7, 8, 9, and 10. So we'll start at the bottom. And the thing about 7, 8, 9, and 10, the only one that I really found as people were turning them into me that people were having problems with is number 8. And that is because it didn't have a base, right? And if it doesn't have a base, what are you supposed to use? It's understood to be a base 10. So if you look at that problem, number 8, it should have been 10 squared. 10 squared equals 100, okay? And then most everybody I saw, y'all did 7, 9, and 10 correctly. But number 8 was the only one I saw people missing. All right? So that's the last 4. That was a review from the night before, from Wednesday night. All right, let's go to the first graph. And again, the thing I want you to notice about the equation here is there anything being added or subtracted within parentheses with that x? No, it was clearly just saying x and then outside of that plus 3. So that deals with a vertical shift. Therefore, it did not affect my what? It did not affect my, start with an A. It did not affect my asymptote. My asymptote stayed on the y-axis, which we call x equals 0, right? X equals 0. So that would the asymptote affects my domain. So my domain was everything to the right of that asymptote, 0. So 0 to infinity. And then of course we said in logarithmic functions, your range is always unlimited. Negative infinity to positive infinity, okay? So that takes care of that. And then of course the only thing you had to find using your graphing calculator was your x-intercept. And in this case it was 8, 0. You could have found that one because it's a nice number. You could have found it in your table or by zooming in and looking at your graph, either way, okay? In fact, all of these were nice for this homework assignment, which was nice. All right, so number 2, if you notice it, a little different from the last one. Notice how x plus 5 was in parentheses with it? Again, that is telling you that it has a shift horizontally. And remember how the rule is? If it says x plus 5, it's actually what? If it says x plus 5, it's actually negative 5 horizontal shift. So that means that thing had to go left 5. And sure enough, if you look at your graph, did it? Did it go left 5? Absolutely it did. So your asymptote moved over to x equals negative 5. X equals negative 5. So that affected your domain, right? If your asymptote moved over, your x values could be everything from negative 5 to infinity. And then, of course, your range was unaffected, and your x-intercept was a nice one to find. So those are only 2 that you were supposed to graph on your own paper, okay? Now the next 4, you were supposed to graph them, but only to find your what? Only to find your, what do we need to find with our graphing calculator? The x-intercept, okay? So here they all were. Let's look at them 2 at a time. Here's 3 and 4. Again, look, that's x plus 8 in parentheses. So that means it had a horizontal shift, left 8, right? Left 8. So my asymptote changed to x equals negative 8. That changed my domain to negative 8 to infinity. So that's what affects your asymptote. And then, of course, your range is always unaffected in logarithms. And then, of course, you just had to look at your graph or your table to find your x-intercept. Look at number 4. X minus 4 is in parentheses. So that, again, is a horizontal shift. It's the opposite, so it's right 4. That's why my asymptote moved to x equals positive 4. And of course, that affected my domain. It's all the values from 4 to infinity. So again, hopefully you're feeling that connection with logarithms and asymptotes and domains, how they are all affected by that shift that you find inside your parenthesis. And if it's not there, it doesn't change. So it's y equals 0 or x equals 0, like the first one we did. So does everybody have those? Any questions over those? Of course, the x-intercepts were both nice ones. You could have found them in your table or zooming in on your graph, either way. All right, and the last two, number 5 and 6, again, just that kind of starts becoming repetitive. You notice on number 5, it's x minus 2. So in parentheses, so it's telling you it's shifting to the right 2. So my asymptote changes to x equals 2. That changes my domain to all the values from 2 to infinity. And then, of course, your x-intercept there is 7, 0. Then on number 6, it's x minus 1 in parentheses, so that thing shifts to the right 1. So x equals 1 is your new asymptote, and 1 to infinity is your domain. And again, 5, 0 is your x-intercept. Okay, any questions over any of those problems? Got all 10 to do, 2 to graph. You're also supposed to name the key characteristics for those 2. Then you're supposed to just name the key characteristics for the middle 4, and then rewrite those last 4 in the opposite form. All right, let's go ahead and move along. If you haven't finished that, finish it. Turn it in. If you have finished it, go ahead and turn it in. If you turned it in on Friday, I'm sorry. Yeah, if you turn it in on Thursday, and it has a check mark on it, you don't have to return it in. It's done. It's graded, and you're good to go. Ooh, you got things other than almonds in there today. Peanuts.
I actually had this last time, but I didn't finish it, so I just kept it in my bag.
Not just a almond day. I see. It's changing things up, mixing things up. What are you doing?
Stapling it.
Oh,
Because I read everything.
put your name on it. A doodler.
Yeah.
How many times do people call you a doubler?
A lot.
I don't
correct them. It's not that big.
You should fight them. The next person who calls you that, fight them. Okay? Get the big knockdown, drag out, fight with somebody. Okay. So today, we are going to solve logarithmic equations. And here's the beauty of this lesson. We've already kind of talked about it in one sense. Let me explain. You remember when we were solving exponential equations? And we did one method. We did the method where we created those bases to be the same. And what were we able to do with those bases once we created them to be the same? Remember? If it was like 5 to an exponent and 5 to an exponent, what could we do with those? We could drop off the 5s, we could drop off the bases, and then we could solve. Remember that? Y'all took a quiz over it and everything, if you don't remember. And I told you when we did that there was one other good way to solve exponential equations. I said you could rewrite them as logarithms. But at that point, we hadn't talked about logarithms. So we've kind of talked about this because today we're going to talk about how to solve logarithmic functions. And guess how many methods there are? 2. And one of them is very much like dropping off the bases. If we have logs on both sides, what does that say we can do with them? If we have a log on both sides, we can do what to solve? You can drop off the logs. And then you take the arguments that are left and set them equal to 0 to each other and solve. So that was real simple. Here's the new one. Okay? If you have log equals a number, you can exponentiate. Okay, you can't drop off the logs, but you can exponentiate. And that's what we spent time doing last Wednesday. How can I take a logarithm and write it as an exponent? How can I take an exponent and rewrite it as a logarithm? This is where it comes in handy. For example, I have log base 2 of x equals 3. So I can sit here and think, okay, how can I find what x is? Well, in this case, it probably wouldn't be that hard to find because log base 2 of a nice number equals 3. But what if it's not a nice number? How would I find x? Well, I can't drop off the logs and solve, so my option is exponentiate. What does that mean? Remember, you can always rewrite a logarithm as a what? Exponent. And here's how you do it. The base of my log becomes the base of my exponent, right? So what is the base of my log right here? So 2 becomes the base of my exponent. So then I do the loop. 2 to what power? 2 to the third power, or 2 cubed, equals what? Equals x. So how can I simply find the value of x? Go to my calculator, type in what? 2 cubed, right? Well, what is 2 times 2 times 2? What is 2 cubed? So x would equal 8. So that's how you do it. It's very simple. You either drop off the logs, if they have logs on both sides, or if it's log equals a number, you exponentiate. That's it. Okay? These are not overly complicated methods of solving. The back is on. Alright, so the one thing that you got to remember is kind of like with radical equations, you can sometimes have solutions that are not really true. We call them extraneous. Y'all remember extraneous solutions? When we were doing radical equations, sometimes you have extraneous solutions. So you got to just check them. And you're going to check them just using your calculator, okay? You're just going to quickly do your calculator, just going to type them in. So that's why you need to have your calculator today. So if it's log equals log, what do?
Drop the log.
Drop the logs. If it's log equals a number, what do? How? Exponentiate. Meaning, write it as an exponent. So if there's logs on both sides, what do? Drop off the logs. If it's log equals a number, what do? Exponentiate. Write it as an exponent. Okay? So here we go. Let's look at some examples. 5 examples we're going to look at. So start with A. First question. Is this log equals a log or log equals a number? Log equals a number. You do not see log written on the right side of this equal sign. So it's definitely not log equals log. So we're going to what? We're going to exponentiate. Okay, what's the base of my log, guys? 4. So 4 to what power? 4 to the second power equals what? 2x plus 6. So 4 squared equals 2x plus 6. That's it. That's all you got to do here. And then, of course, you're just going to go through the process of solving now, which we're going to look at a couple different methods of, a couple different processes of solving today, but this one's real simple. What is 4 squared? So 16 equals 2x plus 6, right? So what's my first move? I want to subtract 6. What's 16 minus 6? So 10 equals 2x. And then what? Divide by 2. So x equals 5. X equals 5. Okay. How hard is that? Is that hard for anybody? Okay, so we're going to check it real quick. We're going to check these in our calculator to make sure that they work. So here we go. This one has a different base, right? So where do we go to type this into our calculator? Alpha, window, number 5. What's our base? Base 4. And what's inside the parenthesis? 2x plus 6, right? But what are we checking? The x value of, what did we just solve for? For 5, right? We got x equals 5, so we're going to go 2 times 5 plus 6, all inside that parenthesis, and push equals. What does it give me? 2. What's the other side equal? 2. Does 2 equal 2? So this one is not extraneous. It is my solution. Okay, so again, checking these with your graphing calculator at the end is no problem. Okay, so we're going to do that. Don't forget, we're going to keep checking them. There's only one time it's tricky, and we're going to run into that right now. Okay, so here we go. Let's go to the right side. B. First question, is this log equals log or log equals a number?
Log equals log.
Definitely log equals log, right? Definitely log equals log, so we're going to do what? We're going to drop the logs. And we're going to take our arguments only and set them equal. What's our argument on the left side? 4x minus 2, right? Y'all going to help me out a little bit? What's my argument on the right side?
X plus 7.
X plus 7. Thank you. So, we drop off our logs. We set our arguments equal to each other. Now we solve. Remember how I like to do it? I like to move the smaller variable first, since there's two variables. So which one's smaller, 4x or x? How do we move that x?
Subtract.
We subtract x, right? What is 4x minus x? 3x minus 2 equals 7. Okay, now what?
You add the 2.
Add the 2. So what's 7 plus 2?
9.
So 3x equals 9. Last step. Divide by 3. So 9 divided by 3 is 3. So let's go check that one real quick. Again, go to your calculator. But do I have to use alpha window number 5 on this one? This is a common log, isn't it? So remember what I can do to make it a little quicker? I can just use the LOG button on the left side. If you use alpha window number 5 here, what do you have to put as your base? Base 10. So I would just use the LOG button, okay, on the left side of your calculator. So type this in for me. Log of 4 times 3 minus 2 equals. What do you get? 1. Did everybody get 1? All right, now go to the right side. Type in log of 3 plus 7. Push equals. What do you get? Does 1 equal 1? For sure. So this one also not extraneous. That's our solution. So we don't write anything, we don't do anything. We just move on, okay? All right. C. Is this log equals log or log equals number?
Log equals log.
Log equals log. So we're going to, what? We're going to drop off our logs. So what was our argument on the left side?
X to the squared minus 4x.
And what's our argument on the right side?
12.
So we have x squared minus 4x equals 12. Now this is why this problem might be a little harder. Can I just solve for x? Unfortunately, I can't just solve for x. Why? Well, I've got an x squared and an x. So I can't just solve for x. So how do we say we can do this when we have an x squared and an x? Anybody remember?
Add them.
What do you mean add them?
Or it's multiply them, but you're adding the 2 exponents.
No. You can't combine the x squared with the 4x. Anybody remember? There you go. We got to get everything on one side, and then if y'all heard what Michael said, he said the two parentheses that have binomials. We have to factor it. So we're going to move that 12 over how? So I have x squared minus 4x minus 12 equals 0. And Michael's saying we gotta put them in two parentheses that are binomials. Remember how this works? What times what gives me x squared? X times x, right? We're factoring it into two binomials. Then we always looked at this sign, remember? It's a negative. So what's that tell me? That one of these have to be positive and one of them have to be negative. They're working against each other, right? So they're multiplying to get negative 12. They're combining to get negative 4. So what we're really looking at is we're looking for two numbers that will multiply to get 12, and they have a difference of 4. What two numbers will multiply to get 12, have a difference of 4? 6 and 2. That's it. Okay, there's three things that multiply to get 12. You got 1 and 12. You got 2 and 3. You got, 2 and 6. And then you got 3 and 4. So you got three different possibilities that multiply to get 12, but only one of them have a gap of 4, and that's 6 and 2. So last thing. Which sign has to win? Which sign dominates when these two go at each other? Negative wins. So negative has to go with my bigger factor. Which one's bigger, 6 or 2? So the minus has to go with the 6, and the plus then with the 2. Does that make sense? Everybody? Does that make sense? Okay, so from here, what do we do with these factors to solve? No, you don't even have to FOIL, because if you FOILed, actually, you're going to end up with this again.
Oh, we're going to 0?
Yeah, we're going to set those two factors, x plus 2 equal to 0. And then we're going to take the x minus 6 and set it equal to 0, and we're going to solve. So with the first one, I'm going to subtract 2, right? So x will equal negative 2. But on the second one, I'm going to add 6, so x will equal positive 6. So there's my two solutions, negative 2 and 6. Now I want to check them, okay? And this is the only trick to checking these. You got to remember, when I'm plugging this back in, notice how this says x squared? Well, what do I have to do when I plug negative 2 back into x squared? I got to remember to put negative 2 in what? So here's how I'm going to do this. Y'all ready? You're going to try both of them. Okay, listen, that's a good question, actually. Let me go back over here. Sometimes when we do these type problems where they have two solutions, some people think, well, I need to put one of them into this x and the other into that x. No, you're trying one x at a time. So if I'm trying negative 2, I'm plugging negative 2 into here and here to check to see if it's a solution. Then I'll try 6 in both those places to check to see if they're solutions. So we're going to try negative 2 first. So look, I can use my common log button, right? But in parentheses, I'm putting negative 2 before I square it. And then it's minus 4 times negative 2. So there it is. It's x squared minus 4x. And since x is negative 2, that's how I'm plugging it in. Now push enter. And we're checking to see if that's equal to log of 12. So do log of 12. Are those the exact same numbers? Absolutely. So negative 2 is a true solution. Now let's check 4. I'm sorry, 6. Let's check 6. So common log of 6 squared minus 4 times 6. I plugged it in the same equation. Does it also equal the same thing, log of 12? Absolutely it does. So these are both true solutions. Neither of them are what? Neither of them are extraneous. All right, very good. Questions about that one? Okay, let's go over here to D. Is this log equals log or log equals a number?
Log equals number.
Log equals a number. So we're going to what? We're going to exponentiate. We're going to write it as an exponent. Okay? So here it is. The base of my log is 2. So 2 to what power? 2 to the third power equals what?
X squared plus 2x.
X squared plus 2x. So 2 cubed equals x squared plus 2x. Now this is kind of similar to the last problem, isn't it? I can't just solve for x because I got x squared and 2x. So I need to load everything on one side, right? So I got to move that 2 cubed. Well, what is 2 cubed? What's 2 times 2 times 2? 8. So I'm going to move that 8, how? By subtracting 8. Everybody with me? So I have x squared plus 2x minus 8. Let me pause here, make sure everybody is comfortable with what I just did there. I moved the 2 cubed over to the rest. 2 cubed, of course, was 8, so I subtracted it. Now, I've got to do what Michael talked about earlier. And what's this called? Starts with an F? I got to factor it. So remember the rule? This times this has to give me x squared. So what's that going to be? X times x, right? Okay, now, we're multiplying to get negative again. So that means one of them has to be negative and the other has to be positive. So they're fighting each other, right? So we're looking for two numbers that multiply to get 8, fight each other to get 2. Okay, have a difference of 2. What multiplies to get 8 has a difference of 2? 4 times 2. 4 and 2 multiply to get 8 have a difference of 2. So it has to be 4 and 2. It has to be. So my last thing is, what sign dominated when they fought? Positive. So it has to go with your bigger factor. Which one's bigger, 4 or 2? 4. So positive this time has to go with the big one, 4, and minus goes with the small one, 2. So it's x minus 2 and x plus 4. So let's set them equal to 0. X minus 2 equals 0, add 2, so x equals 2. X plus 4 equals 0, subtract the 4, x equals negative 4. Okay? Now, go to your calculator real quick, and let's plug them in. This time, can you use your common log button? No, it has a base of 2, so you have to use alpha window number 5, alpha window number 5, put 2 in your base, and now let's check the first value, 2. Go 2 squared plus 2 times 2. So you do log base 2 of 2 squared plus 2 times 2. What do you get? You get 3? Does 3 equal 3? All right, well, then that one's good. Now let's check the other one. Alpha window number 5. Put 2 in your base. And then do in parentheses negative 4, close parentheses squared, plus 2 times negative 4. Tell me what you get. You get 3? All right, perfect. It's done. It's true. So no extraneous solutions here. In fact, none of the notes have extraneous solution. There's one problem in your homework, number 8, that has an extraneous solution. If you want to just mark that, one of them will have it. There's 2 solutions to number 8. Number 8 might be the hardest problem on the homework, but anyways. Let's do one last example. I'm going to show you one thing in your homework, and then you can have at it. Letter E. Is this log equals log or log equals a number?
Log equals number.
It's log equals a number. So we're going to exponentiate, right? But here's the key to this problem, the part that everybody always forgets. Just like we forgot on our homework on number 8 from Thursday night. What is the base of this log? It's understood to be a 10. So when I exponentiate, I've got to do 10 to what power? To the second power equals what?
50x over x minus 1.
All right. So 10 squared is 100, and that equals 50x over x minus 1. Now, there's a couple of good ways you could do this problem. I'm probably going to go back to the one that you guys are most familiar with. Okay. Here's the way I do it. I notice that 50x is being divided by x minus 1. So how would I get rid of that x minus 1? I would multiply both sides by x minus 1. When I multiply this side by x minus 1, it'll cancel. When I multiply this side by x minus 1, I'll have to distribute. And then that would help me solve the problem. Some people don't see that as well, so I like to show you guys an older school way of doing it. You notice how this is a fraction? Could I make 100 a fraction?
Yes.
How do you make any number a fraction? Now all of a sudden you have two fractions set equal. What's the old rule that you learn when you have two fractions set equal? You can cross, multiply, and solve. So that's what I'm going to show you. I'm going to cross, multiply, and solve. I'm going to take it up to the right. So let's do first 100 times x minus 1. What is 100 times x? 100x. What's 100 times negative 1? Negative 100. So I distributed 100 to x minus 1, and I got 100x minus 100. Now, what about the other one? What's 50x times 1? It's just 50x. So that's exactly what I would have gotten had I done it the other way I talked about and distributed that x minus 1 to the other side. It's the exact same method. Okay? It's just you guys are more familiar with proportions, and therefore solving a problem like that makes it a little easier to remember the whole rule of cross multiplication. All right, so how do I solve this thing from here? What do I do to solve? I'm going to do two steps at once. Okay? I'm going to subtract the 50x to move it over here to the 100x. And at the same time, I'm going to add that 100 to this other side. So here's what I'm left with, guys. 100x minus 50x is 50x. These cancel on the left, these cancel on the right, and I'm left with 50x equals 100, right? So what's the last step? Divide by 50. What's 100 divided by 50? 2. So go to your calculator. Since this is a common log, you can just push the log button and then do alpha y equals number 1, do a fraction, and then do 50 times 2 in the top, and then do 2 minus 1 in the bottom, and push equals. What does it tell you? Does 2 equal 2?
Yes.
So once again, we prove no extraneous solution. So there you have it. Now, I want to show you all the ones on the back. I want you guys to take a couple of notes. Number 3, mark it. You're going to have to factor that one. Number 5, you're going to have to factor. And number 8, you're going to have to factor, but I'm going to put, you're going to factor with GCF. Okay, so number 3, factor, 5, factor, and then 8, you're going to factor with GCF. You'll see it when you get there, hopefully. Lastly, let me show you number 7. Is this log equals log? Excuse me. Or log equals a number?
Log.
It is. But are we ready to exponentiate right now? No, there's this weird thing about this problem that we haven't talked about. That's why I want to show it to you real quick. And once we get this done, it's done. Is that plus 15 inside that 28k minus 20? Then you can't exponentiate yet. You got to move that 15 first. How? So when I subtract that 15 to the other side, you're going to be left with log base 8 of 28k minus 20 inside parentheses equals 3. Now, can we exponentiate it? Yes. Okay. So occasionally when that happens, If you have something that's outside that parenthesis, you got to move it first before you go through your process of exponentiating. Okay, so make that change. I don't really want to say change. Simplify that number 7 to that point, and then you should be able to do it. So your homework is numbers 1 through 8. You got some time now to work on this, but it's due tomorrow. Okay, we'll go over it tomorrow. It's due tomorrow. All right. And when I say y'all have some time, you only have like 5 or 6 minutes, but sometime. Any questions?